do the balance. Somehow it is not running because of the, I think, class probability only.
Under something 90, get into 90 degrees.
Which one?
Do under sampling method.
Ah.
The values will get into 90 pieces. Rows.
Yeah.
If you want to submit into submission action sequence.
Test data you will not change, na?
Okay, test.
Once you build the model now, whatever rows may be there in the test data, it will run. Variables must be same, that's all. Rows difference is there, that's not a problem, na? That number of the variables in both the train data and test data should be same. Okay. I am sending the monthly car sales data. For the email ID. I've sent the data set. Create a new project in R. Open any R Studio. File, new project, new directory, new project, car sales production. Create project. Open any R Studio and file new project and create a new project. So 126 observations of two variables. So all of you have created the project. Once you have imported the data, please tell me. Imported, all of you? All of you imported the data? So this is monthly car sales of India from April 2011 till September 2021. Ten years, 6 months. Done, imported. So you have to convert the data into time series data using the TS function. There is a TS function in R that will help you to convert the data into time series data. Car sales TS is equal to TS car sales dollar sales comma start is equal to C of 2011 comma 4 comma frequency is equal to 12 monthly frequency. So once we have done this, car sales TS, the data will be restructured like this. If you see in the console, the data will be restructured as this. On the rows you have years, on the columns you have months. So TS function first give the data car sales dollar sales comma start date is April 2011 comma frequency is equal to 12 because this is monthly data. Now you can plot the car sales TS and you can see the y-axis is time. The y-axis is time means the data has been converted into time series data. Okay, all of you converted into time series. Now you have to install a package called FPP. This FPP will install all the relevant packages required for time series analysis or IoT analysis. FPP. The library to be installed is FPP. Sir, good afternoon. ఇవాళ సెషన్లో ఉన్నాను చెప్పండి. అది ప్రీ టెస్ట్ పోస్ట్ ఇంతకు 10 అడిగాలని ఇప్పుడు 25 అడుగుతున్నారా? 15 ఇచ్చేస్తాను. అదే మరీ 25 అంటే మళ్ళీ కష్టం వస్తుంది. అంటే వాళ్ళకి ప్రాబ్లం ఉంది. 15 ఇచ్చేద్దాం. 15 ప్రీ టెస్ట్, 15 పోస్ట్ టెస్ట్. నా దగ్గర ఆనకొండ పైథన్ కదా, ఆనకొండ పైథన్ 3.8 లేటెస్ట్ వర్షన్ నేను మీకు పంపిస్తాను. ఆనకొండ పైథన్ ఓకే, అదే ఆనకొండ పైథన్ పంపిస్తాను 3.8. So install the package FPP. Yeah. So activate the package library FPP. After installing the package, activate the package library FPP. Library FPP. Now, like we discussed earlier, time series analysis data must be stationary, which means data must have constant mean, variance, and covariance. That is the only thing. No? Let me check once. Stationary time series. Mean variance and autocorrelation. Mean variance and autocorrelation must be constant. do not change over time. Do not change over time. That is the definition of stationarity. We have studied this in Python also, right? Constant data and all. And what is the test? Augmented Dickey-Fuller test. The augmented Dickey-Fuller test for stationarity is the test we have to do for this. What is the null hypothesis? The null hypothesis is unit root present or data is not stationary. Alternate is no unit root or data is stationary. The augmented Dickey-Fuller test for stationarity. The null hypothesis is unit root present or data is not stationary. Alternate is no unit root or data is stationary. How will you decide? P-value less than 0.05. What we will do? We will reject the null hypothesis. P-value greater than 0.05, we fail to reject null. So based on the p-value, we will decide whether to reject null or fail to reject null. So to make sure our data is stationary, we must use augmented Dickey-Fuller test for stationary. The null hypothesis is no unit root present or data is not stationary. Alternate is no unit root or data is stationary. So we should reject the null hypothesis here. The test is ADF.test parcels. Very simple in R, just ADF.test parcels TS. Since p-value is less than 0.05, what we will do? We will reject the null. So if you got any doubt, you can go into the help and type the ADF.test. You will get all the information related to the test in the help window. See, ADF test for the null that acts as unit root. Got it? Stationarity. Yeah. Want me to go up? Huh? Which one? Frequency is equal to 365. Date you can give or it will automatically read. Start point you can give 2011 comma 4 comma 01 or 211-04-01 and then frequency is equal to 365. Weekly is frequency is equal to 52. Monthly is 12. Quarterly is 4. Yearly is 1. Frequency is equal to 1 means annual data. Done? So after this, what we will do? We will do the decomposition of time series. After stationarity, we will be doing decomposition of time series. That means taking time series components. What are the time series components? Trend. Trend can be up, down, or horizontal. Then seasonality based on 4 seasons. Then cyclicality based on business cycles, business or economic cycle. This is a long-term trend. It will not come in the graph. The last one is random or residual or error. It is actual minus predicted. So decomposition of time series is the next thing, where we will decompose the time series. Okay. So plot, open bracket, let me zoom the plot window to sideways. Decompose car sales. Yes. So decomposition of time series, you can see that the trend, seasonality and random is there. Since cyclical is a long-term trend, it is not here. Seasonality looks like a pattern here. There is a seasonality in our data. You can find the decomposition. Seasonal time series. Because car sales is seasonal, no? So I am using type is equal to multiplicator. Additive is for non-seasonal data. For seasonal data, multiplicator. All right, all of you got the decomposition. Then forecasting methods. Forecasting methods. So in Python, we have limited methods, but in R, we have many methods. So one of the forecasting method is exponential smoothing method. Car sales ETS is equal to ETS car sales TS. Summary car sales ETS. So you can see the summary of the model. So the RMSE, the matrix is RMSE, right? So it got an RMSE of 34,376.53. So you have a lot of metrics in time series forecasting. Metrics for time series forecasting. There are many of them. First one is ME. What is ME? Mean error. Then RMSE, which is root mean square error. Then MAE. What is MAE? Mean absolute error. Then MPE, which is mean percent error. Then you have MAPE, mean absolute percent error. And MACE. Yes. Mean absolute scaled error. So these are all metrics you will get in time series data, statistics data. We won't get all of them. We get absolute error in Python. We get RMSE in Python. And we also get MAE and RMSE is what we get in Python. MSE is also we get, mean square error also we get in Python. MAE, MSE and RMSE is what we get in Python. Whereas in R we get a lot of statistics. So here we need to find the model that has the least RMSE. So for exponential smoothing, we got the error as 34,376 units. So let us do the prediction. ETS predict is equal to predict car sales ETS, comma H is equal to 36. We are predicting for next 36 months. Plot ETS predict. So you can see the plot. So the forecast plot we can get say 36 months, next 36 months. We are forecasting for next 36 months, 3 years. Okay. Now, in R, you can also check for the model fitness. There is something called lung box test. Lung box test on residuals. This is done on residuals. So lung box test is also an interesting test. The null and alternate hypotheses are, just check once. The data are independently distributed. alternate hypothesis is the data are not independently, they exhibit serial correlation. The data are independently distributed, the data are not independently distributed, they exhibit serial correlation. This is the null and alternate of the lung box test. Okay, so we can run this test very easily in Python, sorry, in R. Check residuals. Car sales, PTS. So we got a p-value is less than 0.05, we will reject the null. The data are not independently distributed, they exhibit serial correlation. So that model is not good. If the model exhibits serial correlation, it is not a good fit model. So you can see in the lung box test output console, these things you'll get the diagrams also. This is also metric. See, if this in this graph, this is most important. See, if all of them are below the, see the bell curve is flat. The bell curve itself is flat. It is not perfect. So if you get a perfect bell curve and all the histogram boxes are below the bell curve, then it is a good fit model. Then it is considered as a good fit model. So you can see here the bell curve itself is a little bit flattened and the histogram is breaking the thing. So this suggests the model is not good fit model. This is not the best fit model. ETS is not the best fit model. Got it, all of you? You can do lung box test in Python also, but it requires a little bit of residual calculation. We have to first calculate residuals and then we have to run it on this thing, and it will just give you the p-value and the Q star. It will give you the p-value and Q star in Python, stats models. All right. The next method is seasonal naive method. The seasonal naive method replicates the seasonal repetition in the data. Seasonal naive method replicates the seasonal repetition in data. In our data, we have seasonality. That seasonality will be repeated and it predicts based on the seasonality data. So car sales S naive is equal to S naive car sales TS comma H is equal to 36. Summary car sales S9. Summary car sales S9. So you can see here, the RMS is also again higher. The RMS is 57,892. Plot car sales S9. You can see the plot. See, it is replicating the seasonal pattern. See, it is replicating the seasonal pattern. You can see the pattern here. It is replicating this pattern. This pattern is there, right? It is replicating it next 5 years. So the seasonal, this pattern and these patterns are same. So the most recent seasonal pattern, it will repeat. The most recent seasonal pattern, it repeats. So it is replicating this pattern. Had it not been zero, this is a very good model. Because of this being zero last year, COVID, and then afterwards there is again, we have a big fall in data in 2021 May, lockdown again. So we have that pattern repeating. So otherwise, this is a very big model. It replicates the pattern. The most recent seasonal pattern will be repeated. You can see, right? The structure of this and these are all same, right? The most recent seasonal will be repeated. So this is the best fit model for the seasonal data. But in our case, what happened was, again, we had last month sales falling, right? September also we had a huge sales fall. So that's why it is not able to predict properly. Check residual car sales S9. See, again, p-value less than 0.05, we are rejecting the null. Since p-value is less than 0.05, reject null. Seasonal name method. Okay. What error? Did you select TS or ETS? You might have selected ETS. Yeah, TS. The next popular method is Halt-Winters method. Halt-Winters method of prediction. This is based on Halt-Winters decomposition. The decomposition which you have seen is Halt-Winters decomposition. Based on Halt-Winters decomposition method. Car sales halt is equal to halt car sales TS comma H is equal to 36. Summary car sales halt. So RMSE of 38,960. Then plot car sales halt. So it is almost giving like a straight line plot. It is giving an upward trend. Check residuals, car sales halt. Again, p-value less than 0.05, it's not a good fit model. Okay, now comes our major model. Auto-regressive integrated moving average, also called as ARIMA P, D, Q, ARIMA PDQ model. Auto-regressive integrated moving average. Auto-regressive is linear relationship between y and lagged values of y. Integrated is differencing part, whatever differencing you are doing, that one. And then moving average is linear relationship between errors and lagged errors. So auto-regressive integrated moving average. Auto-regressive is the P part, integrator is the P part, and moving average is the Q part, P, D, Q. Auto-regressive integrated moving average. ARIMA. So yt is equal to intercept plus yt minus 1 plus yt minus 2 plus yt minus 3 plus yt minus 4 plus till yt minus n minus et minus 1 minus et minus 2 minus et minus 3 minus till et minus n. Sorry. So here you will get ACF, car sales TS, comma, lag dot max is equal to 30. So you can see here ACF plot, the drastic change is happening only at around 1. No, between this only. 0, 1. So Q might be equal to 1. Yes, here car sales TS, comma, lag dot max equal to 30. Here also after 1 it is becoming negative. So this is your P can be 1. So this we call it as auto correlation plot. PSEF is partial auto correlation plot. ACF and PSEF. So we have an auto ARIMA function here. Car sales ARIMA is equal to auto ARIMA car sales TS. Summary car sales ARIMA. So we got a model with almost 36,734. ARIMA predict is equal to predict car sales ARIMA, H is equal to 36. Plot ARIMA 36. That means this is forecast, not predict. So ARIMA is also predicting a downward trend. This is a robust model compared to all other models. See, so the best ARIMA model is here. This is the best model 010 with seasonal parameters. How I forgot. The best model is seasonal model. Now we have seasonal in data. Is ARIMA 010 These are seasonal parameters. Remember, and the frequency is 1. So this is seasonal model. This is a seasonal model with RMSE of this. And if you look at check results, we ultimately got a model since p value is greater than 0.05, fail to reject null. That means ARIMA is the best fit model. ARIMA is the best fit model. Which graph? Only one. That is a normal thing, no? Say this is a normal distribution factor, right? These are closely. This is not a perfect thing, but among all the models, this is the best fit model.
So by observation, we have this.
No, we will go to the p value. No? We'll go to the p value. Okay. Now we will implement the Facebook profit model. Facebook profit model. This is also a forecasting model developed by Facebook to predict forecast receipts. So you have to install packages profit. Library profit. So we will use the original data here. Car sales. Okay, all of you have installed the package called profit, library profit. Okay, now if you see str, the date is showing as character. If you look at the str function, the data structure function, it is showing the date as character. If you look at it, the date is shown as character. So we have to convert the date to date format. So car sales dollar date is equal to as dot date car sales dollar date. Now I'll run the str command again, and then I can see the date format is gone. Huh? Okay. Oh shit. I have to re-input the data. So you have to give format is equal to double quotes. My format is in %d hyphen %m hyphen capital Y, because mine is date, month, and year. So now the data has been perfectly corrected. Correct? Now we have to change the column names. Column names, car sales is equal to C of S, comma, Y. Change the name of the columns to date as DS, data as Y. M is equal to okay. Model is equal to profit car sales. Summary model. Not summary. Print model. So linear, and it is identifying the change points. 25 change points. Yearly seasonality auto, weekly auto, holidays nil, seasonality mode additive. Forecast for car profit is equal to make underscore future underscore data frames model comma periods is equal to 36. Profit forecast is equal to predict plot car profit. Why it is saying like this? predict model comma, that is the problem. Profit predict is equal to predict model comma car profit. Plot profit predict. Plot model comma profit predict. We can see the predicted also. It's predicted an upward trend. So this is the complete profit code. Reverse time series. And I also got the weekly graph. We got the yearly graph. Just check once, comment, run one more time. There was some error which happened.